Find the derivative of the function. There is no need to simplify your answer. The function we are looking at in this case is f of x equals secant x squared plus x to the 20th power. With this, we will need to use the chain rule. As I see, we have an inside function and an outside function. So our derivative will look something like this. F prime of x equals, when you use the chain rule, it says take the derivative of the outside function. Since it's a power 20, we will just bring the 20 to the front and subtract 1 from the power. And we will leave the insides alone. So I'm going to write secant x squared plus x on the inside of that set of parentheses. And to that, we need to multiply the derivative of secant x squared plus x. Now in this derivative over here, we have a normal power rule for the x, so the derivative of this term is just 1, but this term requires another chain rule. We have a function that is secant and another function inside of that which is x squared. So we have the x squared is on the inside and the secant is on the outside. So we need another chain rule for this derivative, but just for the secant part. And since we have this already as part of our answer being multiplied to this derivative, I'm just going to do some work over here and find the derivative of this function. And then at the very end, I will multiply it back to 20 secant x squared plus x to the 19th power. So the derivative of this function is the derivative of the outside secant turns into secant tangent, and we're going to leave the x squared on the inside alone. To that, we will multiply the derivative of what's on the inside, in this case x squared. The derivative of x squared is 2x. So all of this is the derivative for secant x squared. This last bit over here, plus x, again, just use the power rule. That is adding 1. So we have this entire expression that will be multiplied down here as part of our answer. And there is your unsimplified derivative.